Okay, let's discuss a few very fascinating applications of computer vision. If you, for example, see this particular video, courtesy by Tesla, that's a self-driving car, and they are becoming very, very popular these days. Everybody wants the intelligent car driving, the object detection, the obstacle detection, automatic lane change. If, for example, a driver is slippery or maybe tired, or there are night scenes and stuff like that. So these cars basically are much more intelligent and applying brakes, changing lanes, and to do all kind of safety driving. And now here you can see the driver is not actually driving the car. These are the intelligent systems that are doing all that stuff. What is happening under the hood is, one, they have a lot of cameras, typically more than one. And through these cameras, they are detecting these lanes, staying in these lanes, detecting the objects around them, keeping a safe distance from the upcoming object, staying in their lane. The safe distance is sometimes called the tailgating kind of stuff. And they also have certain maps available, so that not only they are detecting everything through the available road, but there are some maps that are helping out. But the situations are much more dynamic, and most of the computer vision techniques, they are actually deployed, and they are becoming very, very fundamental in self-driving cars. And a lot of companies are actually investing in building these kind of cars that are actually the computer vision engines and computational machines. Actually, they are not just cars. They actually gather a lot of data. They decide a lot of stuff. Self-driving cars, one of the very fascinating applications of computer vision. Other applications of computer visions include, for example, the object detection. And here I'm showing you a video of the object detection that is from deep learning, the YOLO object detector. We also have discussed this in our course, as well as in our other course on convolutional neural networks. You can see this is all real time, and given a video or an image, we want to detect the objects. You can see how fast that is. Actually, in this particular course, I have shown the efficiency and the libraries to actually implement that. But think about, given an image, I want to detect all the objects, and not only detect where the objects are, I also want to detect what that object is. I also want to detect the identity of that object. And that is possible through computer vision techniques. That's a camera. A camera is giving us an image, and image understanding techniques, whatever that technique is, fall under computer vision. And in this particular course, we have discussed the object detection in detail. And you can have, for example, this kind of results on your own video, no problem. So that's object detection, very, very famous, not only detecting the bounding box of the object, where the object is in the image, but also is detecting what this object is. How cool is that? Yeah. So that's object detection, other than self-driving cars. But don't worry, there are other very cool applications. Think about multiple camera scenario, and a person entering in the first camera looks like that, and the same person in the field of view in another camera looks like that. And similarly, see the examples, this person and that person, very different in the pose. Similarly for this person and for that person. And look for this person and the same person in another camera. So the goal of re-identification is, if a person is viewed in one camera and the same person is there in some other camera, we want to link that this person is exactly this particular person. And if you, for example, see this image, it is very, very difficult to actually link this image with that image, although the both are same. So the re-identification techniques in different companies and in different areas actually tries to build the track of people, where they are at what particular time. The same re-identification techniques help actually the shopping mall people to actually manage the personal kind of products or the recommendations Same kind of re-identification techniques are very, very helpful in audience measurement for customized advertisements and stuff. And same kind of this kind of re-identification techniques are helpful in tracking different kind of people, maybe employees or students in a particular vicinity. Not a big deal. But this re-identification at the end of the day requires a lot of images or videos to be processed by computer vision techniques. Yeah. So last but not the least here, if we have a lot of images of a 3D structure, and if we want to build a 3D structure from the images, again, computer vision will be helpful. Not for just the rigid structure, also for the non-rigid structure, the structures that are changing over time. And this is true for modeling the face. This is true for modeling the 3D shapes and animations, building very cool animations, animations that are very, very realistic by building the 3D models of the objects by computer vision techniques again. And if you ask me why computer vision, I will ask you, by the way, why not? We can do face recognition through computer vision. We can do the 3D pose estimation of human body of any structure, whether that structure is rigid structure over time, whether that's a non-rigid structure, that's changing its structure over time. We can estimate its pose. We can have smile locks, for example. Earlier, Sony released a smile shutter that was if you when a group of people, when they smile, only then the picture is taken. Although you have given a green signal for the capture, but the capture will only happen once the smile is done by the group activity. Yeah. And based on the capture, you can have a smile locks on your phones. For example, whenever you smile, the phone locks. How cool is that? Activity recognition, what the people are doing. Maybe in bank, a particular kind of activity is not allowed. Maybe for example, on the rooftop at the midnight, the appearance of some person is suspicious, and maybe appearance of some person and doing some further suspicious thing is again maybe very, very suspicious and maybe notified automatically. So building smart CCTV cameras that fall under computer vision. So why not? Group analysis. If you, for example, see a particular group of people is coming, and by analyzing their culture just through their appearance, their gait style and stuff, you can offer them personalized ads to whole group that maybe this particular food you may like very well. And can you imagine crop health monitoring? Computer vision techniques are even very fundamental to find out the health of the crop, to actually give suggestions to the farmers by taking the images of the crop by the drones or satellite imagery, by doing some hyperspectral imagery, by having some hyperspectral imagery and applying computer vision techniques. You can find out the crop health, the water content in the crop, what is required, what is not required, and you can all give that to the concerned farmers and give them suggestions what to do and what not to. So my question, and much more, and my question would be, if you ask why computer vision, I will ask, why not?